Okay, give me a cue when you are live. Okay, good afternoon, namaskar, and good morning, good evening to the people who are joining from other time zones. So I am your host for this session. My name is Neeraj Kumar. I am Director at National E-Governance Division, Ministry of Electronics and IT. So for this today's session, which is from data rich to data intelligent, how can countries navigate the waters? I welcome the two eminent keynote speakers, that is Dr. Gaurav Aggarwal from Google Research and Mr. Prakash Kumar, CEO GSTN. So Mr. Prakash Kumar, he is having a diverse and rich experience from being an IAS officer and serving various governments of states of Delhi, Arunachal, Andamans and Government of India. He has also served in private sector companies like Cisco, Microsoft, and now he is the CEO of GSTN. So for my viewers, I would like to inform that GSTN is responsible for major tax filings in India and collects about 1 lakh crore of Indian rupees per month to the government. It is our privilege to have you here, sir, as a keynote speaker. Welcome. Also, we have Dr. Gaurav Aggarwal. He is a BTech from IIT Chennai and a PhD from University of Maryland. He also brings immense experience in building computer vision and machine learning solutions, both in academic and industrial settings. So we are happy to have you as keynote speaker and moderator for today's panel discussion. Welcome.
Thank you.
So we will have 20-minute keynote address from both the speakers, from both the keynote address persons, and thereafter we will have about a panel discussion for about 60 minutes and then 20 minutes of QA session. So this session is very important, as you know, that India is one of the most data rich countries in the world through initiatives like Unique ID, that is called Aadhar in India, and various projects of Digital India like UPI, GSTN, Digital Locker, and Unified Mobile Application Umang, which provides more than 1,450 services of the central government, state government, and municipalities under single mobile application. So India has immense potential to utilize these insights for societal good. This session will delve into the transformation of intelligent data repositories that can catalyze AI innovation. And I also want to inform that India offered 1 GB of mobile data to its users at just 9 cents, which was the cheapest across the world compared to global cost of mobile data. The same amount of data was available in developed countries at much higher rates. That is about $1.39 in UK and about $8 in the US. So now I invite Dr. Gaurav Aggarwal to give his keynote address. So Dr. Gaurav.
Thanks, Neeraj. I will try to share my screen. Hopefully there will not in English. Can you guys see my screen?
Yes.
I'll go to the present mode. Cool. Thanks, Neeraj. And I'm like overwhelmed really to be part of this session with so many, dignitaries, people, someone like me look up to sort of learn and become them in future, hopefully. So thank you for having me here. I have sort of lived my life as a researcher, so my take on this will be a little bit on the research side, technical side, and how I have seen the importance of data in my work in past couple of decades. See, data is like think of it like labor force, right? I mean, if I were to say, you can have a lot of people, but if they are not skilled, it's not very useful, or at least not as useful as it can be. Similarly, data is similar. Like obviously, any country with a lot of people, any place, you say like web is full of data. Yes, it is, but maybe not all of it is very useful or in a usable form. And that's what I'm going to highlight through some examples, through some anecdotes to see like how we can play a role here actively to make ourselves data intelligent, not just be happy with that we have a lot of data, because most of it is not in a usable form unless we work hard on it. So, I mean, the simple example is water rich. I mean, this flooding, this is an image from floods in Assam. I mean, no one will call this place, water rich. I mean, it's not just flooding doesn't mean we have a lot of water and we will not have a water problem. Similarly, I did my undergrad from IIT Madras. So this is a picture from Marina Beach. And I remember my days there, we used to play Holi and there was hardly any water in the hostels after we are done. And we used to really go to the sea beach to actually wash off all the holy colors. And so with all the water around Chennai, there was still no water to even take bath properly. So I think just being water rich in this case or data rich is not sufficient. What you need to be is intelligent. How do you navigate this water? I mean, this is example. So this is exactly the same thing with data. Like you need dams, you need to channel it to different places. So it's not just flooding people, but rather it is being put to proper use. I think it's a perfect analogy for data. I mean, it's everywhere, but can you put it to good use? And that requires effort. Same thing with solar power, right? I mean, India is a hot country by most standards, but unless we put like solar panels in the right places and use them to generate power, it's not very useful. So now I give an example from my personal experience, very recent experience actually. So as part of my work at Google Research, we have a division of Google Research we call as AI for Social Good, where we try to work with NGOs and people from academia in India to help them solve many of their problems using data, because like that is part of our mission here in Google Research here in India. So I started interacting with this NGO called Swasti, and I thought I should not just discuss things over emails and data, but I thought I will visit their office, right? So I went there. I was like, okay, tell me what all data do you collect? They have like thousands of beneficiaries they work with. They collect data. They have like 21 different forms.
Mute your mics, all these speakers.
Thank you. It's fine now. So I went there. I asked them, what all data do you collect, just to get the lay of the land, understand what I'm getting into, what can be solved, because they haven't done much of data analysis or things like that before. So they showed me like 21 different forms they collect. I mean, it's painstaking job. Their health workers go around talking to beneficiaries, collecting data week after week after week. And there are like 21 different forms of different kinds. Some are patient-centric, some are some disease-centric and stuff like that, finance-centric. So I was happy. I was like, with so much data, we can be so impactful in targeting. What do we do with these people, right? I mean, you can be so targeted. It will ease the job of your health workers to go about doing it. And they said, okay, take it. I said, okay, how do I take the data? And they said, okay, it is in our ledgers. This is it. So they have like, heaps and heaps of ledgers that they have been collecting for years. And the data is just this. In fact, I asked them to take a few pictures for me, but it's never digitized. And their point was like, we are already resource constrained and we can't have a human sort of enter these things into a computer. And that's how like data actually in India, a lot of data looks like in India. And while one may think like the way research has progressed in computer vision, optical character recognition, it's probably not very difficult to digitize this, but reality is far from that. I tried using state-of-the-art algorithms on these documents. It doesn't work. So basically, to make this data mainstream, to do, and it is not just about Swasti in particular, right? I think you go to our police department, legal department, anywhere, most of the data in India, in the older data at least, right, it is in this form, and unless we put it in a form that can be utilized, that can be analyzed, exploited for the right reasons, it is not very useful. So again, data is there, but not in the form that anyone can use. Other thing I bring here is like India is slightly we are far behind and little far behind compared to US, China, other countries with regard to our number of people who are involved in research in AI, so to speak. We have a long way to go. So in this scenario, in fact, this was suggested by Dr. Sunita Saravgi from IIT Bombay yesterday in a panel, that if we have the right data sets, what we can do is we can take help of researchers around the world to help them solve our problems, basically. Today, most of the research in, whether it top AI conferences, machine learning conferences, is actually done on data sets. Most of them are curated and developed in US. And that's why most of the, the innovation happens on those problems. For example, like if you talk about autonomous navigation, that's not probably the problem for India. But a lot of people, a lot of companies do research on that, because the US government sort of enabled that through grants, through data sets, through challenges. And I think that's exactly, we have to take a leaf from how US has done it, and whatever problems are important to us, we sort of create these enablers, starting with data, to help people help us, basically, in a way, especially in the situation where we have far few researchers in our country than what we need. Another slide on the same thing. There are challenges of this, why the standard OCR doesn't work. These forms are typically multilingual. That's how we Indians are. It's typically Hindi, English, and another local language. In this case, Kannada, Hindi, and English all mixed together. When we write, we obviously write over the tabular lines, and it's okay. Humans can still read it, but computers actually find it hard. Then we use short forms like data science and stuff like that. So this is not an easy problem. But if we were to, given the importance of such a OCR based system, if we were to able to create a data set painstakingly, digitize it may not be in Excel sheets, but at least digitize and create a challenge problem around the world, and take help of researchers to actually compete for that challenge problem, I think we can get a lot done. In fact, I'm trying to do that in this case. And just to highlight how important this is, I don't know how many of you have heard of ImageNet. I think the hype around AI and machine learning is so high, deep learning particularly is so high. I'm pretty sure even people who are not too technical, they would have heard of these terms. But probably not many people know about ImageNet unless you are doing research in this. ImageNet is a data set that was sort of started. This effort was started by Professor Fei-Fei Li from Stanford. And this actually, whatever we see, the reason we are having this conference, in fact, raised, right? I mean, it's all about AI, right? If not for ImageNet, I think we will not be having this conference. It's a data set. It's not an innovation. It's a vision. Like, they collected more than 1 million images, and they created challenge problems and asked people to go about doing it. It was very hard. In fact, the accuracies in the early days of ImageNet were really, really low. They were like 30-40% accuracies. But this gave this gave a goal, an objective, an ambition for people. How can we be so bad? And in the past less than 10 years, I mean, the sort of innovation we have seen, a lot of the credit has to go to ImageNet and its innovator, which Professor Fei-Fei Li from Stanford. I think this is like the watershed moment for deep learning or machine learning. I think we need such watershed moments for the problems we deal with. And I cannot overstate the importance of a well-curated, well-intentioned data set. And obviously, you have to do the groundwork to make sure some researchers get excited, then more researchers will take the leap. So they have to be hard. They have to be, they have to be aligned with the research challenges. And then it is like, then the fun will happen. It's like making something viral on social media. So it's the same thing with research community also. So these things act like enablers to make something viral in research community, and that's what we need in India actually to solve a lot of our problems. Data sets existed even before ImageNet. I mean, they were just, it's not like this was the first time a image data set was created, right? I mean, research has been going on forever. But just that the vision, the ambition, the challenges posed by this were like of 100x more than what anyone has ever seen, and that sort of changed the entire focus of the research community. And we, again, I can't highlight it more. This is exactly what we need here in India for our problems. And these are a few slides from Google Trends. And as you can see, so this is for machine learning, how the trend for machine learning has changed. And the top graph is for US and bottom one is for India. So India is slightly lagging behind US, but it shows around 2000. So this ImageNet was released or conceptualized in 2010. It started becoming popular in 2012 onwards. And you see the sort of the trend of machine learning becoming popular based on Google searches is around the same time. It's like, it's obviously lagging a bit because first research started showing results and people started becoming interested. I mean, the general public is obviously lags a little bit behind research community. And it shows like, this exactly shows like how this data set played a huge role in making machine learning mainstream. Just to give an anecdote, I still remember when I was doing my PhD in Maryland back in 2002. I remember my elder brother was like, you're done with your master's. Why don't you leave? I mean, who does PhD in machine learning? No, I mean, it doesn't work. So, I mean, you won't get a job after this. And that was his comment in 2004, and how things have changed. And a lot of credit has to go to not just research, but this curation of these critical data sets. And this slide shows how the accuracy on this data set has improved. So it was like, as I said, it was like in 2011 using traditional techniques, it was around 50%, which is like, pretty bad. I mean, now if you look at, now we are hitting 90%. It's still a hard data set. Even humans make mistake in this. But as you can see, the like literally lakhs and lakhs of researchers just spent their days and nights on this to actually get us to this. And the reason was the well curated data set. Now I will, from this, hopefully I have motivated the importance of a data set. I will give an example of some positive work that is done by a friend of mine. Here in the picture, the person on the left is Dr. Pravesh Biyani. He's a associate professor at IIIT Delhi. And on the right is, I forgot the name. So he explaining the app to the health minister of Delhi, state of Delhi. I forgot his name, sorry. And so what they have done is like, so, while metros are popular in urban areas, but I think a lot of lower middle class, lower poor people still travel by buses in our country. And if you can imagine, I mean, what is the difference with metro and buses? You don't know when it will come. I mean, even if person, you or I need to take it, the biggest problem is the unreliability. So you want to create a system where all the bus data, where they are, where they go, what time, what is the frequency, everything should be at the tips of the people, users, right? And this is exactly what Pravesh did. And they worked with, state of Delhi, and the motivation to make this data, transit data available, transit for buses, and have this information available to the users, our passengers. And what it does, it makes the unreliability go away. This is not so much about research, but it's about how the availability of data can actually change the lives of people for such a common use case. So what they did is in almost no time, and this was launched like a month ago, they already have thousands of buses which have this GPS device, and they are putting it out there in open, and it's open. So any app, Paytm or Google Pay or Phone Pay, or anyone can use this data and start selling these tickets. And the benefit is for users is they can actually see where their buses are and how long they have to wait and stuff like that. And the reason is it's not a novel idea again. So that is the key here, right? I mean, in this example, public transit has been around forever. I mean, it's not a new thing. And open ticketing, where a private player can come in or anyone can come in and use this data to start ticketing, is again not a new idea as such. But I think the way it enables people and the way it enables the innovation in transit is mind-blowing. So next slide sort of shows the little demo of how it works. So we have bus GPS data, and we put all this GPS data on an open transit data sponsored by the state of Delhi, and then that goes to any ticketing app that you want to build. So what it does is there is this QR code app, QR code in the buses, and a user will scan this code. It will get to know the information about which bus you are, what is the current stop, where you want to go, and you buy the ticket using your standard UPI interface, and you're done. So this shows the flow for a user, but the flow which is not shown here is like when you're waiting at the bus stop, you exactly know the ETA. Like you wait for Ola and Uber. How long will it take? The bus, how long will the bus you are waiting for will take before it arrives. And so you can plan your travel better. Small thing, but these are the small things that matter actually. And in very, as I said, it is barely 2 months old, and already more than 1 lakh tickets have been sold. There is one route where more than 13% of the passengers have started using this way of ticketing. And very soon it will be available in all buses in Delhi and hopefully other places. So this is one simple example of how making data open can actually change the lives of people in a small way, but a small but effective way, make them more efficient and not waste their time waiting for their buses. And just to stress the point again, I mean, we have problems of air pollution, agriculture stress, agrarian stress, traffic. I live in Bangalore, so I can't overstate the difficulty of traffic, public health, conservation, the problem of endangered languages, which I think Vivek is also going to talk about today. The problem is we have not put enough effort. While there is, I mean, again, data around, right? I mean, you can say we have AQI data about Delhi. We have some data about how, about weather, about how agriculture distress has been around, about traffic. Obviously, our traffic police departments have enough data. there are cameras at many places. But again, this has not been put out in a form that researchers will start working on it to actually solve these problems. And that's my request, and to all the other speakers in today's session and others who are watching, if you are in a position where you can actually play a role in making these data not just available, but let's work together to get it in a form that researchers around the world, not just in India, can help us solve these problems. These problems are not unsolvable, and maybe we can't solve them to the fullest, but I think we can definitely reduce the pain. I mean, it's that time of the year. I'm pretty sure, like, within 15 days, we'll start hearing about the AQI levels in Delhi, and the problem is, like, still I have not seen a comprehensive, usable, good grand challenge around this problem. I think, given how many people get affected by this every year in Delhi, I think we need to create data sets that people can work on and solve this problem. Government alone can't do it. So, but what government can do is help private entities, NGOs, and work together to create this data set. I think solution will happen by itself. No one entity can solve it. These are hard problems, obviously. Otherwise, they would have been solved. And with this, I'll end my keynote, and thank you for attending it, and thank you for giving me a chance to share my views.
Thank you, Dr. Gaurav. It was very well, very much informative. You informed to the audience that how data sets can be used in research, and not only the Indian researchers, but even the global researchers can use this data, and the importance of well-curated data sets. And you also indicated that we should use the distribution network of Google, Paytm, and Flipkart. This was a new concept. So earlier we were talking of the distribution network in terms of the physical networks. So this is a new concept which the government should be using it, because it has been seen that government is trying to, all the departments are making their own mobile application or website, but they can also put forward their products here and services there. So that's a good concept. So thank you, Dr. Gaurav. Thank you very much. Now I invite Mr. Prakash Kumar, CEO GSTN, to deliver his keynote address. So
thank you very much, Neeraj Kumar and Department of Electronics and IT for giving me this opportunity. Unfortunately, like what Dr. Aggarwal was talking about, what data we have is personally PII and lots of personal information. Now, we can't put it in directly in public domain, but then we are doing some work on that. And that is what I'm going to share with you. But before I get into that, I thought, let me share with you the quantum of data which we have. We have around 12.76 million active taxpayers who have filed 500 million return on this portal in last 3 years and 3 months. And that also includes around 9.9 billion business-to-business invoices, which have very detailed data, seller, buyer, quantity of tax, quantity, etc. Then the payments made, which Neeraj talked about, around 14 billion US dollar equivalent is paid every month on this portal. And so far, 386 billion US dollar equivalent has been paid on this portal. And also we enable people to generate electronic waybills so that trucks can move freely from one state to another. And we have various kinds of data sets, which I'll just explain. And also we have data, we get a little bit of data from income tax, which is the this is the PAN, which is identification number given by our tax department. And that is gross taxable range of the entity. And also from customs, we get taxes paid on import and what kind of commodity they are importing. So this is I'm just getting into details so that this is what our building block is on which we have built our AI applications, where we have firmographic data, details about the firm. Then we have about the promoters. Then we have about all their additional places of business, what items they deal and all that. Then of course we have ledgers I don't need to get into. Returns we have multiple, 2 types. One is very, very basic, which you make payment. And then another one is where you give your all business to business invoice data. And then we have electronic waybill, where how the goods are moving from which place to which place, which invoice it's carrying, what item it's carrying. And this enables us today to know what gets produced at zip code level in a country and what gets consumed at a zip code. Now, this is a very, very powerful data, which my friend Dr. Gaurav Aggarwal will certainly nod on that. Then we have payment data, we have refund data, we have customs data, we have direct taxes, and then we have lots of back-end process data, like when an audit happens, what is the result? Whether some additional tax was found to be paid by that guy. If an enforcement activity happens, then what happens? And then when he goes on appeal, what happens? And then if a cancellation is done of the registration, why it was done, what was there. And these, the data sets we have used, and our focus areas are four. First and foremost, since we are a tax department, to detect tax evasion. And the second one is revenue assurance. The third one, that is what I'm going to talk about today, is creation of insights for policymakers. The data which we have has impact or can be used by other ministries, departments. How do they use it? And that is what I'll briefly touch upon. And then all my taxpayers, what I can give them back. That's also very important. And then what we do, we have reports, we have tools, we give leads to our investigators that these are the guys who are, you should go after them. We give the dashboard to the taxpayers and tax officers, and also a tool for selection of taxpayers for audit. You just don't pick up randomly. You go after someone where the data tells you that this guy is a potential mischief maker, go after him. So what are we using? We are using rule-based as well as machine learning. In fact, one of the panelists here, Dr. Vivek Rachman, is also our guide for some of our teams. And under his guidance, some of the tools have been developed using machine learning. And we conceptualize, identify the cases, and development is done by our partner, Infosys. Now, briefly, I'll tell you about the areas where our tax evasion related things are, like gap analysis. When they give business to business and also a basic return, we find out where the gaps are. Or they claim input tax credit, which is like your taxes paid on your purchases, how that we compile from all suppliers' data and then compare and find out. Similarly, from electronic way bills. So that's the gap analysis we do. Once you identify gaps, we need to find out the chain, because these guys, they, in fact, what they do, we started finding out. So they move the goods on paper 20 states, and then they will bring it and sell it. What is called carousel trade in Europe, similar, something of that sort. So we, in fact, Vivek was the person who guided the team to create this tool, where we can now find and go up to multiple levels and identify who the guy is who has done this. Then related party analysis, you give me one number, a tax identification number, a PAN number, or a mobile, and I can tell you how these guys are connected in our system, who all are using, how they are connected with each other. Similarly, we do lots of anomaly detection based on ratios out of data from annual return, monthly return, and also cluster-based anomaly detection. Then we do risk profiling. Like when a new taxpayer comes, our system is basically, again, a machine learning based system, which ranks it, scores, and tells the taxpayer that, look, this is the score out of 10. Higher the score, more carefully you need to look at. In fact, in the higher, very, very high score, they go and verify whether the guy is existing there or not. Similarly, refund risk scores are also given to the application. And again, we have an overall risk score of our taxpayer. Then we give some visualization thing for our tax officers or the senior level people, how revenue is getting generated, where the gaps are, how the filing is taking place, and things of that sort. Last three buckets we are still working on is to identify sudden spike by people who come into our system to take advantage of that. So we have developed some techniques, and that's basically a POC is going on. Similarly, on trend analysis of revenue forecasting, predicting tax payment default. That's also one of the important part which we are working on. And predicting propensity of a taxpayer to cancel e-way bill, because that's again relating to misuse of the system. You show that as if you have sold the goods, but actually you haven't sold the goods. You create the e-way bill as well and then do it. So these are some of the things which unfortunately I cannot go more into detail because I can't tell my recipe to my ultimate users. But then let me show you how some of our aggregated data could be of use to others. One simple thing which we have done, since we get harmonized system of numbering, which is nothing but commodity code, which is of World Customs Organization. So we have used that and created sectors. So similar like items have been put together here. What you will see here, machinery, mechanical appliances like in one group, precious metal in one group, textile in one group. So that's a sector we have identified. And then below that we have product, and below that we have chapters. So you can drill down to the last level. And this basically shows at the whole country level, this is for the export, which area we are exporting, what we are exporting, how much is being contributed. And you can see it nationally, you can see it for the state, you can see it for the sub-state. Then another thing Ministry of Commerce does, like machine, what we export and what we import. And there is a ratio. So we have created for them so that they know what is our import export for sectors, for product, or for even for chapter. And then you can go down level to individual items as well that we have not created because that level of data is not being filed, which we are going to get from the next financial year from the taxpayer. Then this is what the tile diagram shows, that you select a sector, then if you click on that, then it goes which are the services under that, and then you can go under chapter, and what all the tiles which you see here basically tells you what is the turnover contribution or what is the tax contribution based on whatever selection you have done on the filters above. Then the tax department or the finance department wants to know a trend analysis. How is this sector doing in last 8 quarters? How is it done? So this is what we are going. Same data, but now quarterly put for state, for the whole country, or for sub-state. And we can also do comparison, and you can go up to month level also. So basically we have given them tools so that they can drill down the policymaker and see. You can see in the below bottom one, there is something which is called a construction project. Now, out of 8 quarters, there is 1 quarter which is a huge peak in August. I asked the tax officers, why is a such huge peak? Now they are trying to find out why this particular peak is there in a particular state. Then how do I compare 2 states? So here you can compare 2 states, compare 2 products, you compare 2 sectors, different kinds of comparisons you can do. And that's why we have given XY, both axes, different kinds of items to choose and do it. So this is basically we have done for our commerce and customs and such other agencies to use this data. Next one is, our data has now been used for the first time by Ministry of Statistics and Program Implementation to validate whatever GDP figures they generate. So they have taken from us and of course aggregate data. They tell us and then we give them aggregate data. And then they're validating that what we get and how the way they calculate, is it similar or not? The second one is something very interesting, which I'll talk about is, in our country, we have like on our electronic waybill portal, 1.8 crore, which is 18 million unique commercial vehicles, which are used to generate 2 million electronic waybill every day. Now, what happens? The trucks we don't have very formal market. So if they are owned, 1 or 2 truck is owned by one person. So it's highly fragmented. And that's why we have large number of intermediaries. And we have a problem of dead miles. We have a problem of wait time because they have to ask their own agent. That agent will ask someone else. A truck from Delhi has gone to Chennai. Now the Chennai, he will call up Delhi fellow. Delhi fellow will call up his counterpart in Chennai that I have a truck which wants to go back to Delhi. Do you have material? Now we thought that we have this data like what Google Map has, and can we provide this to people who can create applications on top of that. It will be free to people to create applications. So we only provide truck visibility, and so that we can ensure more number of trips for the truck. It will have impact on the environment because the dead mileage will go down, cost cutting reduction and all that. And what also we have seen that more than 1,000-kilometer journey is just around 15% of the total e-way bill generated. So what we are going essentially doing is now we are going to have this data, what we call truck visibility and positioning platform. That's a public good which we are going and creating and putting it there. And then encourage these companies to come on top of that. You create application and you provide bidding platform to truckers or agencies and the buyers of sellers and consigners, consignee, and whosoever gives the best service, people will go there. And this is a public good which we'll provide down below, where we have data from electronic vehicle system and also from our central registry of vehicles, so that they get validated data of the truck. And we will also provide them some rating based on their past performance, because now we have 2.5 years of electronic vehicle data. This truck, how many truck trips it has done, how many times it was caught carrying undeclared goods and things of that sort, that will be added in future. So that's one project which had just started, and we are a POC has been done and will be in fact coming out to select bidding companies. Not select, to allow them. The second one is before GST came in 2017 July, the tax structure was such that every state had its own, like the way you have in US. So forcefully, large companies had to maintain warehouses in every state. The moment GST came, they removed that. And now they have made it based on their own estimations of supply chain. But what you see here is on the left-hand side, suppose I need to send my factories in Gurgaon, which is close to Delhi, and to Coimbatore, which is placed near Chennai. Today, they send it like this because I don't have a full truckload. What I'm sending, there are 5 other companies also, and all the products are put in a truck. Now they go from Delhi to Gurgaon to Nagpur. Some of them which are meant for Nagpur gets offloaded. Then something new gets added. It goes to Chennai and like that. Now this data, which we have around 300K per day, and if we put it for 30 months, it has 270 million data set on all the routes which we have, which tells where the vehicle stopped and for how many days the goods were. So like in Nagpur, goods meant for Chennai, for which all cities went through Nagpur and how many days they had to spend there. Now, is Nagpur the really good place to have a hub, or something else could be done? And this could be used by our National Highway Authority of India or such other Ministry of Transport to create new hubs, and especially when they are creating these long freeways which are going from south to north or east to west, for that kind of thing. So this is a new thing which we have just created, and we are getting into a POC mode, that how do we analyze this data, 270 million data set, on multiple routes. We know which are the most important routes which are used today. But then can this be used to improve our hub and spoke model? And the idea here will be, again, to put it in public domain, let people analyze this, and then come up with good systems for that. So then the third one, and the last one which I have, I think I'm coming too close to my time, is there is a entrepreneurial readiness of countries, which is done. And every country is, they have pillars like opportunity perception, risk acceptance, networking, public internationalization, human capital, product innovation, high growth, startup skills, competition, technology absorption. Now this we are exploring, can we, and lots of data is available with me, with GST system. And some data we'll have to take from census, from income tax, and some other sources. And then we can create an index for all the states, how entrepreneurial that particular state is. So far we generate it on very limited data, but this we will give you like what indicator international they use, how many women entrepreneurs are there, how many young entrepreneurs are there, what is the rural urban distribution, what is the average age of an active business, how quickly it gets cancelled, how many companies with have international partners or promoters, then what kind of slab, how much money they're spending on their wages, because that also shows what area they are in. More service industry, intensive industries have higher salary and wages and things of that sort. So this is again a new area, and through this forum, all the listeners who are listening, I will be urging them to give us ideas. Tell us, you have seen what, and this presentation I will share with the host. What else we can do? This is a data set, but we have to remember one thing: all individual data, nothing can be shared. We don't even share with sister departments, ministries. But aggregate data of GST or electronic way bill, like I mentioned earlier, e-way bill knows exactly which pin code, zip code to which zip code, what item moves, and where it gets ends. Now, this is again a very powerful data. So what can we do out of this? Of course, fintech companies are interested to know individual data so that they can do scoring and do lending. But that, unfortunately, we can't do here and put it in open domain. But the aggregate data, which is good for society, can always be done. So these were some of the things which I thought I will share. And the last slide is about what I can do for the taxpayer, which we have already started working, to show him how his business is. And this is more for small and medium enterprises, that what is your monthly sale purchase chart? What you're showing in your return and what you're showing in electronic way bill? If there is a gap, we warn them. What is your tax to your turnover ratio? Is there any sudden peak somewhere? So things of that sort, and sudden jump, and then some other financial parameters, sudden changes, so that he is or she is aware that I should not do something wrong, and this is what it is, one. And the second one is, this is very helpful data, especially for SME sector. Big guys always get it from their CFO and from their consultant. This is more for small people. So that's all I had. Thank you very much. I just took exactly 20 minutes. Thank you, Neeraj, and over to you. I'll stop sharing.
Thank you, Mr. Prakash. You familiarized us that GSTN is having humongous amount of data, and what gets produced, where it gets produced and where it gets consumed, how to catch troublemakers in the tax systems. And you also told that visualization is possible, how much tax is going to be generated to the government, trend analysis of revenue is possible. Truck visibility I was excited to know about that. Even this is the unknown advantage of the GSTN, that even the people who are running their trucks, they will be able to know that how to return and what to return to cut down the dead mileage, and even where to create hubs on the freeways by the NHI. So these are the things which in the beginning even nobody could have thought, but these are the very good consequences or after effects of this. So now I will invite Dr. Gaurav Aggarwal as moderator for the panel discussion. And I also want to leave few thoughts with the panel, that when Corona happened and the workers started migrating from the big cities to the smaller cities, there was a proposal to take a dump of all active mobiles in a city, say Bombay, and to compare next day how many mobiles disappeared from Bombay. That means these people must have migrated. And to also compare this dump to the people who appeared in Bihar or UP, to find out, okay, if they are the same people, so that means you can know that how many people migrated from Bombay to a particular state and in particular city, Begusarai, for example, and government can find out whether they are being quarantined or they are being given medicine or they need any help. So this is similar to a tax or the truck getting appeared or disappeared in the GST system. Here you have the mobile system. So, but there were a lot of questions of privacy by the concerned officials. So one thing has to be decided uncontroversially, that what can be mapped, how much data can be used, what is privacy, what are the boundaries of the privacy. So we have all seen the legal battles or debates in case of Aadhar, which went up to Supreme Court. So I would like the esteemed panel to enlighten all of us benefits of using the data, how the departments and governments do not intrude the privacy, but still use the data for overall good and good for the individual. With these words, I will invite Dr. Gaurav to take us through this exciting panel discussion.
Thank you, Neeraj, and thank you for having me as the moderator also. And thank you, Mr. Prakash. That was illuminating and very fascinating. And I'll probably bother you with an email or phone later on to know more. And yeah, so just to answer your question, Neeraj, so in Google, we tried to release some of the mobility data before I get onto the panel for world governments and NGOs across the world. So what we did is like just to make sure that privacy is preserved. So we compute these aggregates, as Mr. Prakash also talked about. So the aggregates are computed only when you have some certain number of people. So as you said, so don't talk about, say, Gaurav going from Mumbai to Delhi. I mean, that's too personal. I mean, that's not right. But you can say, and you can first that number, say K number of people, or don't even say K. I mean, just some unit, maybe first that unit, some X unit went from Bangalore to Delhi. That's okay. I mean, no one knows. And do that only when you know that there is like sufficient number of data points that moved from one place to another. Otherwise, given how things are, and as we heard stories about, some people were socially outcasted, especially when the cases were fewer in number. Now I think they are everywhere, so we have gotten used to it. But I think initially, because it was like within a kilometer or 2 kilometer radius, if we had someone, we will literally try to avoid that home or go even near that. Now, I think as long as it is not in our home, I think we are okay. So just to prevent that social outcasting in this case, or in general, it is too private an information. So the one way is aggregate data, I think, and share that aggregates only when there are sufficient number, right? So that it cannot be traced back to an individual. I think it is important. We do it in everything we do in our corporate world. It is important even in, even if the goal is for public good, I think it is important to provide that privacy. I think all of us deserve it. In this today's connected world, otherwise strange things can happen. I think it is very important. I can tell you like how hard it is for me as a machine learning practitioner to access any data, even my own data sitting inside Google, because it cannot be, no way, right? So that must be honored, no matter what public good we have in mind. And I'm glad to hear from Mr. Prakash that he highlighted it, stressed on it again and again, that it is PII and they can only give aggregates even to sister government departments. So with this, I'll move on to the panel discussion. And for the first panel member, we have Dr. Vivek Rachman. I'm delighted to introduce him here. I have known him for a few years, and I'm always in awe of how much he has done for things that we are so used to now. So just to highlight some of his biggest achievements, he's a chief product manager and biometric architect at UIAI. And Vivek has also been chief technologist for Team Indus, India's entry for the Google Lunar X Prize. He has spent 20 years in the field of electronic design automation. I think this is like a very small brief on what he has done, but I think most good technological innovations we see coming from government of India or government of various states, I think Vivek has some role to play, as Mr. Prakash also highlighted. So I'll let him talk about what he's up to next. I don't think he's going to talk about biometrics or Aadhar or any such thing, but something new that that will improve our lives in this country. Thank you, Vivek, and over to you.
Thanks. So can you see my screen?
Yes.
Okay, just a second. Let me just
Now.
So thank you. I'll try to be brief today. As I have been involved in a few government projects, but today I don't think I will be talking anything about my involvement in government projects. I'm actually going to be talking about building data sets in the open domain. Mostly. And there is one government thing which I will talk about, which is towards the end. But most of my focus is actually building open data sets and techniques to build open data sets and why open data sets are important to us. And this is in the public domain as opposed to some of the work in the government. Maybe some other time we will talk about things. So I think the key things, and I think is that, creation, and I think this was also came in a previous session yesterday. I think Professor Sunita Sarogi said that, we have to create open data sets for ecosystem innovation. And because if you don't have, and I think that's one of the fundamental parts of machine learning, right? If AI and machine learning, if you don't have the data set, then you can't do anything. And there's two ways you can look at it, right? One is that, hey, I can, let me wait till the data sets come. Or the second approach is, what tools and what things can I do for the data that's around me? And for example, as what Gaurav said, right? All those data that is there in all of this, in those registers, that data is sitting there. It's not accessible. We need to do something with it. So actually, then what can you do in different domains to actually create open data sets? And the second part is, and here it is obviously the big companies, the Googles and even the the companies like that obviously have a tremendously systematic approach to collect data. But if we see it here in the public sector, whether it's an NGO or whether it's even a government department, that consistency of collecting data and having it in a form that can be usable in the future, that makes sure that every ounce of data you collect is important. And then of course, the question is, leverage existing data. And you do a leverage existing data by creating sometimes simple pipelines and utilities to make the data accessible. That's really the key thing. So, I mean, I think one of the things that I've always, and this is an idea, and that actually, if I look at, and I've worked with the different governments and different entities, and I think that one of the things that you see is that here I'm also here, let's be very clear. I'm here not talking about public data. I'm not talking about PII data at all in this case. But the key thing is that you have to have a systematic approach to collecting data. And I think actually building some of these tools and utilities that can actually collect large scale data while being privacy preserving, and also in a form that is usable in the long run. These are certain basic principles, and if certain open source tools existed for creating these kinds of things, that would be dramatic. And I think that, and obviously there are a number of things. There is obviously, now we have so many sensors. There is a concept of digitally timestamping to make sure the data is accurate, and also it's signed probably, so that you make sure that it can't actually be, so you understand it's actually been captured. And then, you have to have an attention to systemic long-term data storage. And I think these are things which in big corporations are actually taken for given, but we see that in our public systems, and especially, we have to create very, very simple tools where people don't even need to write code, but whenever they collect data, the data is collected in a manner that it can be used intelligently by people in the future. Now, after that, I'm going to actually talk about 3 specific areas where I have interest. And one is data sets, machine translation, speech recognition, and medical data sets. And we're going to talk anonymized medical data sets, and we'll talk about all. So first, I mean, I think this is obvious. India is a country of many, many languages. We have 22 official languages, 6,000 plus dialects, and we actually have 55 languages with more than 1 million speakers. And translation now is obviously an important is an important thing. So one of the things that we did was we said, okay, that today, if you want to use translation, there are obviously lots of commercial tools that are available. But the interesting thing is that those commercial tools that are available, we don't have the data sets that are behind them, and then we also don't have, but they don't exist data sets. So one of the goals here is actually to create for all Indian languages to create a largest open parallel corpus for Indian languages, and at the same time then use these parallel corpuses to build open source translation models. And this is not to prove that we are better though the goal is to actually achieve state-of-the-art results, but the whole point is that we want to make sure that the quality of data set is good enough so that it then becomes available to the ecosystem and to be used by anybody and so therefore these are open models and free to use models. And then, of course, in the end, when to collect the data itself, the whole point of OCR being available in a smooth manner in all index scripts for things that, so the goal is to actually provide all these kinds of utilities and data sets and models for basically providing to actually spur innovation in the translation ecosystem. So, and we do all kinds of interesting things. We actually scrape multilingual data from all kinds of places. We actually do, from all kinds of places. We actually have built these pipelines with multilingual open source OCR. And then we actually build parallel corpuses automatically by doing various kinds of using various kinds of alignment tools, which actually use AI in themselves. And you actually use existing tools also to generate parallel corpus. So we want to create data which is of a massive scale. Like today, for example, if you look at translation data between European language, which is English and French, or English and German, there's a tremendous corpus. While if you look at the amount of parallel the parallel corpus which is required to train translation in, for example, Hindi, in Indian languages, in Hindi, there are certain great work which has been done by IIT Bombay and places like that. But I think there's still the amount of data that's available here is very, very small. And we want to use automated tools and techniques to create a massive parallel corpus and be the largest parallel corpus of data in multiple in as many Indian languages as possible. Of course, and yeah, so we're building a whole bunch of utilities. And in addition to that, we want these models can be created and people can use it, make domain specific models free to use for anyone and can be used. We're also building utilities for interactive translation and things like that. So a whole bunch of things related to that. We have created parallel corpuses in 9 Indian languages. We also have translation models in 9 Indian languages. Our parallel corpus is going to be open source. When it is open source, it will be the largest open parallel corpus in these languages, probably in the next few months. And we are also providing these, and here everything we're actually leveraging only open source things. We're not actually building anything, and everything that we're doing is being contributed back to open source. And we're also, we have also released a beta of the interactive translation capability. The similar thing is work that we're thinking about, and so the point is that this is an open source project. We want anybody to come and help us, and the idea is that it's and the goal is that we don't want data to be the competitive advantage. We want that these languages, whether it is speech or whether it's translation, these are languages that belong to us, and we want it to be open, and we want everybody to contribute together, so that the data is not the differentiator. And in fact, lots of innovation can take place, that people can build better and better things because of the open availability of this language data. Now, similarly, we're doing similar things to actually scraping and trying to build audio to text corpuses in the case of speech recognition. And obviously, there are existing tools that do all of these things, but we want to create open tools and open data for actually looking at some of these areas. The goal is actually create at least 10,000 hours of open speech recognition data in all Indian languages. And, and we are collecting raw data and pre-processing to different kinds of automated pipelines and utilities. And we will prove that this data is valid by building state-of-the-art models, but that's not the purpose. The actual purpose is that data is the real output, that the ecosystem can use it, and they can use our models and further tune for their purposes. And again, the goal here is again to try. And again, this is useful only when we try and make it a movement where people can actually take control of their own languages and actually have the data to actually take advantage of these wonderful open source AI tools that exist. And while we do this, we're doing obviously lots of utilities of different kinds of scraping, identification of language, identification of speakers, different techniques, clever techniques to do transcript generation and quality checks. So therefore, the intent is really to try and build these utilities. This all will be open, and ideally, the way that we want to go is that today, if we do it for some other language, somebody else says, I want to do it for some language, then all the open tools are available for them to actually do this and actually build and take control for their own language. I think that this is a very recent project, but still we have done these techniques. We've actually collected 5,000 hours of audio and text data. We are going to open source this data, and we've trained models also. And then same way, we are going to collect open source data sets for all languages. So I think this is, I mean, so that's, and then the last part of my talk is slightly different. This is actually something that that is again an idea of where maybe data can be used to dramatically change things. One of the things that we do have is that we have this Ayushmandhara Scheme, which actually provides insurance for 10 crore families. The interesting thing is, based on consent and based on anonymization, the healthcare providers can be mandated to actually provide these kinds of lab data and imaging data that they have with all the personal identification, the PII is removed. And if that is available in a dataset repository, which could be hosted and which has anonymization and privacy preserving by design, then this could actually be the largest dataset to immediately try and understand public health insights. And that could be a unique benefit to Indian researchers and startups. So hopefully, as part of this presentation, I've talked about 3 ways where data sets can drive innovation and help us to move to a better place. Thanks.
Thank you, Vivek. This was fascinating. So when are you moving from 9 to maybe, I don't know, to hundreds of Indian languages? So 9 is still like tip of the iceberg.
No, you're absolutely right. That's because that will be when it's a movement. I think we have people to own their own languages and do it. So if one person sits and do, even 9 is large. But I think that if we provide this as open and everybody does it, and if we make the tools available that people can do it, then it's a way. And we want to make it open to everybody. To government wants to use it, to whether it is whether it's companies want to use it. There's no restriction. The goal is to actually make data available to spur innovation.
Thank you so much. It was fascinating, Vivek.
Thanks.
With this, we'll move on to our next speaker, who is Ms. Elaine Tan. She's an advisor, Office of Chief Economist and Director General, and Head of Statistics and Data Innovation Unit in the Economic Research and Regional Cooperation Department of ADB. Her work at ADB includes building statistical capacity in developing member economies, undertaking economic research using new data sources and methods, and providing support and policy advice to ADB operations. Earlier, she was with economics faculty at Royal Holloway, University of London in the UK, and with the Ministry of Trade and Industry, Singapore. She also had a doctorate in economics from Cambridge University, UK. Welcome to the panel, Elaine. Over to you.
Thank you, Gaurav. Let me begin, first of all, by congratulating the organizers of this conference, the Ministry of Electronics and Information Technology. I think that this conference is very, very timely. And I think it shows great foresight by the government of India in recognizing that we need to discuss how to align the potential of AI with social empowerment and the greater good. Because without discussing these important issues, we will never get there. And so this exciting conference, I've attended a few sessions, really provides a very good opportunity to do just that. So congratulations to the organizers and thank you for having me. And since other speakers at the conference have already covered very well the IT and legal aspects of artificial intelligence, let me offer a different perspective. I would say that to be data rich, countries would need to have established strong legal frameworks, advanced IT systems to collect, digitize, curate, process, and analyze the data. And the ability to link different data sets, what Dr. Vivek talked about, requires the right skills, the techniques, as well as computing technologies, advanced computing technologies such as cloud to hold all these very large data sets. But once a country is data rich, how can it extract intelligence from the data? How can we link observations and predictions from data science to explanations and to policy solutions? How does a country make a leap from the ability to assemble and integrate different data sources, data richness, to interpreting the data, to joining the dots and deriving action plans for the government? In other words, how do we move from IT and algorithms to policy impact? And I would suggest that data intelligence requires a multidisciplinary team of different talents. And what kinds of talents will depend on the use cases. Besides IT experts and data scientists, the multidisciplinary team should include domain experts, specialists, policymakers, and policy implementations. Each of these experts have their own roles and perspectives, and they play important parts in moving from data to action. Let's take one example, and I think Gaurav was on point when he showed the pictures of the flood. So let's take one example of a policy question. How can government reduce flood damage in a city? In a city that has frequent flooding, how do we reduce damage when that happens? So policymakers should first of all be part of the team from the beginning. Why? Because they set the question that data are supposed to answer. And more importantly, by participating in the data analyses, they come to understand the insights and limitations of the findings. And in the same team, we will also need domain experts. In our example of flooding, these experts will include specialists in water and sewage management, climate change, land use management, and so on. And the role of these experts is to work very closely with the data scientists to identify the relevant data needed to answer that question and to offer explanations. And of course, we have IT experts in the team who may offer ways to collect new data. For a flooding example, we can have IT experts to bring in remote sensing data using satellite imagery, using drones, or even to build a network of water level sensors throughout the city. And one possibility, of course, is to install water detectors in lampposts, smart lampposts, to create an early warning system for floods. Now, with all these inputs, the data scientists can then build up a necessary understanding of data used, how it's collected, and then which algorithm to develop to answer what question. So for instance, after crunching the data scientists may find that floods tend to cluster around some parts of the city during certain months of the year. They are then able to predict when and where flooding would occur. Domain experts then can come in to help join the dots by providing explanations to the data science model. For example, climate change specialists could explain flooding in certain neighborhoods near the coast due to rising sea levels and more intense rainfalls. Water and land management experts could provide insights on why floods may cause greater damage in some neighborhoods compared to others. And these explanations might include the softness of the soil, the size of built-up areas, and so on. And policy action will then vary depending on the explanations of these data science findings. If rising sea levels are the reason, climate mitigation plans could be a policy solution. If land use is the cause, then policy solution would be changes in land management policies. So my general point is that data science models provide the insights from a data-rich background. So with all the IT and data infrastructure, data science models can be applied to provide insights. However, we need something more. We need the explanations of these data insights from domain experts to create data intelligence that governments can act upon. And policy implementers can also use such intelligence for planning purposes, for changes, for planning development changes, and so on. So I would say that no one person will have all the necessary talents to move from data richness to data intelligence. And having multidisciplinary teams requires different agencies within the government to work together to create agile project teams to solve very specific questions. And then these agile project teams can disband afterwards. So perhaps to relate to what Dr. Prakash talked about, perhaps a team, an agile project team might look at your data set to answer specific policy questions, but only your agency staff can access the individual records. But there's a team that can access the aggregated data to develop policy solutions. And of course, that's just the short run. In the longer run, governments may wish to relook at university course curriculum. We should include data science skills when training domain experts, such as in health, resource management, or engineering. And government servants can also be trained in data skills and the appreciation of data. And similarly, on the flip side, when training data scientists, universities could let students select areas where they can systematically apply their data science skills. So this will allow students to obtain experience in analyzing issues within a specific domain. So for example, a university student in data science now could minor in climate change, and they look at all the big data related to changes in the climate. So innovations in education, I would suggest, can close the gap between having a lot of data and having actionable data intelligence. And when you have those innovations in education, we will get the natural outcome of creating a culture of data intelligence, which will naturally unlock the richness of data sets that India and other countries already have, both in the public as well as the private sector. So let me stop here, and thank you very much. And let me hand back to the moderator, Gaurav. Thank you.
Thank you, Elaine. Thank you for your amazing ideas. So yeah, it is fascinating to hear the importance of different specialties, expertise needed to look at policy decisions. So I think it provides a very interesting perspective. And thank you for that. With this, we'll move on to our next panel speaker, Ms. Sharmistha Dasgupta. She's DDG at NIC and heading Center for Excellence in Artificial Intelligence, working in field of computer vision, natural language processing, conversational AI, deep learning, and high-speed computing. Thanks, ma'am, for being part of the panel, and over to you now. We can't hear you, ma'am. Maybe you're on mute. We can't hear you, ma'am.
Yeah.
Thank you.
Can you hear me? Just a second.
Yes, now.
Hello?
Yes.
It's open now.
Yes, now we can hear you. Yeah.
Can you hear this thing?
Yes, we can hear. You can start. You again muted yourself.
Can you hear me?
Yes, now.
It's
Just
good now.
check the records. Hello?
We can hear you, ma'am, now.
Yeah, thank you. Good afternoon, everybody. Today, I will speak on some of the learnings of Center of Excellence in AI at NIC to help gain insight into how to move to a data intelligent work culture. Basically, we have from the advent of internet in late 90s to cloud, and then mobile computing, and now high-speed supercompute being made available, India has bolstered its digital infrastructure and has tried to build bridge the digital divide. With cloud and internet available, we had mission mode projects running for benefit of all citizens, by which millions of records in citizen assets creation and other government infrastructure creation was made possible. From citizen toilet construction to house construction, roads, wells, schools, to weather forecasting and soil health, fertilizer distribution from factories to farmers to finance, all contributed to make multifaceted, rich data sets for both urban and rural India, which can be harnessed for better policy making, enhanced transparency, and better governance. So how do we proceed to build a better digital work culture, which is digitally intelligent? So identify the problems ground up. To make AI a success, We don't need to think where to apply AI, but we need to think where is the problem and how best we can address it. Like in Swachh Bharat Mission Urban being implemented by Ministry of Housing and Urban Affairs, we had around 5 million individual household toilets created by citizens. Citizens got the scheme benefit as direct benefit transferred to their bank accounts. Final one after construction of toilet and uploading of geotagged toilet photo with beneficiary in the frame. As happens in large schemes, there were delays in processing before release of final installment and citizen complaints on the help desk. So we explored how AI can help in speeding up the process in assisted decision making. Images were annotated, AI models built for constructed toilet seat detection and beneficiary detection. A mobile app was facilitated for the citizens, informing them of the status of photo upload. In case of incorrect photo upload, they could upload correct photo immediately without having to wait for it to be got rejected by sanitary inspector of their ward, thus cutting down significantly on the workflow cycle. Once this was done, we could extend to a similar problem of Ministry of Drinking Water and Sanitation, which had 100 million such constructed toilet images by rural Indians. They wanted to know if people were getting scheme benefits by submitting more than one application, which was not possible to find out normally by any number of human beings. We extended the same image analytics to do image similarity index for detection of duplicates in the photos uploaded for the constructed toilet. So basically you are refactoring the same work which we could do for urban India, we could do for rural India also. And we just annotated only 16,000 data because we were doing binary classification, means whether a toilet seat is seen on the photo and whether a beneficiary photo is there, which is matching with the photo which was given at the time of applicant. So like this, we could, with 16,000 images done, that means on 0.0002% or 3% of the image annotation, we could do 10 crore images or 100 million images. So then next is first after identifying what are the problem we are facing, the next step is identify and build upon your organizational capacity and innovate. So when an organization starts out, it may be struggling to find a direction to take, how much resources and manpower, finance and infra to invest on emerging technologies, how to organize data it has, whether it has the required data to start AI, etc. Although we may need lots of data, maybe in tens of thousands of records to build a model, we may not always be in a position to gather this amount of clean data. Sometimes you may not have any data at all within the organization. But let me retrace the path we have built. We have followed for building up conversational AI portfolio. We are at the forefront now with 12 chatbots in production and 20 more work in progress for different ministries and departments. How did it all shape up? We worked with both open source and proprietary technologies and virtually no data except a few FAQs given by users. We built a virtual assistance by NIC Vani framework to extend support to users, trying to build bots for different departments. We started with open source Google Dialogflow NLP engine, where we gave the ministries the freedom of static content placement on the Google engine, and the model were retrained from feedbacks received as and when it needed improvement. We then allowed APIs to be built to gather the data from the systems of that particular ministry department. The personal data of citizens were handled by our Vani framework without sending it out of NIC Cloud. We use proprietary Nuance voice platform for building voice support and are now building an open source conversational AI engine in-house with the help of our technology partners, NVIDIA, and with the corpora we have built over time. So build small, identify capabilities. It may be data or technical manpower or infrastructure, and then take on bigger steps. If you can identify where are your weaknesses, you can move to bolster your effort in that. I mean, you can explore, outreach, and collaborate. We collaborate extensively with domain experts for domain knowledge and in model building with our technology partners, and simultaneously also do outreach programs for capacity building of our officers with Institute of Repute, imparting training and skill development on machine learning and AI. We also build an AI platform as a service to facilitate high-speed compute to our NIC officers looking after central and state projects to work on a myriad of AI projects. Some important projects being undertaken in collaboration with our NIC counterparts in states include Meghalaya working on life certificate pensioner through detection through face and voice recognition without having to basically come to the bank or something like that. For the elderly, it will very much facilitate. Then West Bengal working on mobile app-based group attendance for facial recognition, through facial recognition for skill trainees, skill development trainees for Utkarsh Bangla. Then we have had Chhattisgarh working on audio to text to visual cue for hearing impaired children in Hindi, and Assam state unit working on for the Assamese children in Assamese, and like that many more. We have built a portal https://ai.nic.in by which we share metadata and our use cases. If a model is giving a good accuracy, it is also shared through APIs, and if required, even model artifacts are shared. So the motto is explore, build, evaluate, collaborate, and if needed, reiterate. Build on the data. There is requirement of huge amount of data. Annotations for training the model. Nowadays, models are built with semi-supervised learning. Part of it may be unsupervised learning, but mostly supervised learning with annotated or labeled data. See, like when we worked with on motor accident claim petition for assisting lower judiciary by giving a cognitive search for similar cases. If somebody gives a petition, then we should be able to find out similar cases having same type of compensation and citations also. So we first started out with English text extraction, and then we did for Hindi by translating it, and then we started with OCR PDF. So there might be different ways. Okay, so what we did for unsupervised learning is we took from Wikipedia, which has got about 2.5 billion words, so that the language model is prepared unsupervised. You don't need to do anything. It will just put the wiki corpus and train your system. Then we build on the top of that legal text jargon so that the system can speak the same language. After that, for building a classifier, we supervise classifier depending on what are the petition's exact values for like age, income, etc. So similar type of case to be shown. So that type of data we are annotating. So basically, you have to have a mix of both. We have to be very careful in not introducing bias in our data. So what we did is we took all the courts, all the states courts were represented, some of the other, which we did only 5% of data annotation, text annotation for this. It is here that diversity of our country plays a major role. Data science pipeline have to be built consciously, and robust mechanism needs to be in place to check what data has been fed to models. Because with deep learning models with nonlinear functions of millions of parameters, it is not possible to explain an AI model, but it is verifiable. That is, enter similar data and it will give you similar predictions every time. There are many algorithms emerging by the day, and mostly there is concept of transfer learning. That is, download the open source model that have worked globally and modify the last few layers, customizing it to our data. Moreover, the final AI models in the software are usually proprietary, and the customers pay by transaction load. And the vendor may not reveal the model artifact, model code, or the artifacts created. So our data policy frameworks should be strong so that what goes into the AI model is separately scrutinizable. Now then, knowledge building to power the economy. Next step, organization mostly have done well with data which conveys explicit knowledge that can be programmed and used for decision making. Usually these are the values of the decision makers. However, this data too happens to be in silos, and only very few organizations exploit the full potential of data sets with assets with them. There is also tacit knowledge in the organization and in the community at large. There are values for the people at large. These need to be converted to explicit knowledge. These are patterns in the data which can be harnessed. This is where AI comes to picture. Current AI approaches are built on the premise that most of the tasks can be codified and algorithmically performed. They are also adaptive in that they try to gather the human experience from the data and improve in accuracy over time. We have to realize that the systems have no intrinsic value, and while AI-based artifacts are developed to efficiently perform highly routine tasks in stable and controlled environments, cognitive awareness might be applied to generate new ideas by applying wisdom. The problem emerges when technology developers attempt to develop computer models in order to substitute this skilled, creative, reflective human action in AI-based artifacts. So we have to be aware of this trap. With AI assisted models and human value chains intact in decision-making process, we can build intelligent and empowered societies. Like, see you in the screen, you can see that we have built a conversational AI bot, iKhedut chatbot for farmers in Gujarati. What we use, Matra transliteration services of API of NICU. It is available in Bharat API. It gives you 11 languages in which you can type in an English keyboard, and that language can be used. So we built, this has been built on Google Dialogflow engine only, but with Gujarati sentences and responses also in Gujarati. So like that, we have to innovate and see what can be done to reach the maximum amount of the citizen and build intelligent societies. Also, we have to respect the data privacy. It needs to be practiced among citizens to share data for social good. Further, we need to respect data privacy. As systems are becoming intelligent in inductive reasoning, best to define knowledge categories and data requirement for each category to facilitate creating intelligent data repository and accordingly share metadata. So for gathering this tacit knowledge of communities to build communities at large, data policy frameworks need to be in place for data anonymization and data sharing agreements based on exposed metadata between user communities. The more we have policies in place, the more we can democratize the use of data. So this is another of our work which we have done, BOPD teleconsultancy services during the COVID-19 times. We have used automatic speech recognition and text-to-speech and natural language understanding and IVRS-based support. Means it is a basic facility on a phone by which a person can call up the emergency, call up the hospital, and then he can wait in a queue, and he can talk to the doctor, specialist, and other. If there is a case of emergency, then that person is also told to visit the hospital. So this was started in lockdown, and we had also tried some more cases. So thank you. I have shared some of my experiences in this line of work with esteemed audience. With this, I would like to wrap up. Stay healthy, stay safe. Thanks.
Thank you. Thank you for the fascinating sharing the stuff that has been going on at NIC. So it's pleasantly surprised and amazed at how much of machine learning and AI is already being used. I think sometimes we need to probably we probably don't hear about it enough. Sometimes it is just in our other daily news, some of these amazing work done by government departments never get highlighted. I think we need a forum where these should be discussed more. Thank you for sharing so much, and really fascinated by all that has been done. Now we'll move on to our next speaker, is Professor Ivan, who is a professor at Skolkovo Institute of Science and Technology. He graduated from Moscow Institute of Physics and Technology in 2006, got Candidate of Sciences degree in 2007, Doctor of Sciences in 2012, both from Marchuk Institute of Numerical Mathematics of Russian Academy of Sciences. He joined Skoltech in 2013. Over to you, Ivan. Thank you for being part of this panel, and looking forward to hearing from you.
Thank you, Gaurav. Yeah, so it's a pity that it's online, but yeah, hope it will be solved. So yeah, so it's interesting to hear the diverse panel of the speakers covering different angles of the questions about data, and indeed there's a lot of data coming, and we slowly learn how to collect the data, build pipelines. It's still a major issue, how to make a correct pipeline for data collection and data management. And we have at Skoltech, we have a lot of experience, for example, for working with medical data. And it's not so easy to collect good medical data, even if you have, for example, healthcare providers.
Ivan, we can't hear you somehow.
We lost
so
your
which is also a challenge.
It's back now. We can hear you now. Thank you.
Yeah. So I maybe the connection is not perfect at the moment, but it's okay. Yeah, but I didn't say anything important yet. So I would like to cover issues that will come. I would say they are already coming, but when we'll face when we have this big data science models for large data set deployed in the critical areas. So AI solutions in the critical areas are already being deployed at the massive scale. So for example, one is biometric identification. So your face, your voice, your behavior can be used as your unique identifier. And this would be used instead of, I don't know, document. And as far as I know, in India, it's already implemented, and everywhere it's useful to access your vital information. Machine learning algorithms
We lost your voice, Eva.
so it can.
It's intermittent.
But I think I lost. But let's try again. Do you hear me now? Yeah. Okay.
Yes.
Probably yes. Okay.
Yes.
So
Yes.
okay. Sorry for my connection again, but
no worries.
Okay. So and it follows the same paradigm, right? So you collect the data, you train the model, and how you find that the model is good, and you basically train on a separate sort of test set. So supervised learning. So of course it now moved to unsupervised learning for improving the quality, but again you do multiple testing. But there are a lot of challenges which I would like to discuss in this. So you have a large model, which is a black box deep learning model, and what are the challenges? And these models are getting bigger and bigger, as already discussed in the keynote today. But we do not understand the theory. Why, if we make a model bigger and train it on the same data set, you still get improvement of the accuracy? The current mathematical theory behind that does not explain. So if you look at the statistical learning theory, it would say that you need not millions of, ImageNet is large, but it's only 10 millions of images. And even a small machine learning model has hundreds of millions of hundreds of millions of parameters, billions of parameters. And why this model doesn't overfit, that it should work. It works, but at this point is an empirical sort of miracle. So we know that more data is better quality. We know this larger model is better quality, but this quality depends on the method how we test those models. And I think that would lead to a lot of problems when we get the deployment of these models at really large scale. Why? So for example, if you build a model and you use, for example, it to identify persons, then there is something called adversarial attacks. So you can make a very small perturbation, imperceptible to human perturbation, that will make the machine learning model to be mistaken. So this is already actually in many places, for example, for face ID systems, for example, kind of research of this type, and it's possible for current model. So they are non-robust. So if they are non-robust, so you have to make them more robust. And then there is a lot of research in this how to make them more robust. But if you make them more robust, they are not so accurate. So it's interesting to see that how it will evolve. the second issue that the prediction are very difficult to explain. So why this particular solution has been chosen. So for face identification, it may be not the big issue. However, if you have, for example, the financial thing, like why this person has been given the credit or this person has not, you have to explain. And there is, of course, discussion, what, do we need explainable model or not? But for some areas, for sure, we need explainable models, for example, for medical applications. If you have large data sets, really big data sets, they often encode human bias. So they encode some decision that were made by humans, and this could be racial bias, this could be gender bias, and so on. And this is well known that if you train, if you use a model trained by Google or someone, for example, for other races, the predictions will be less correct, or they will be really biased. And it's not so clear at the moment how to remove this bias from the model so that the data intelligence does not increase this bias of the previously collected human knowledge in the new model. And finally, I already said that at the moment we do not collection of images, of good images, it's a big problem. And we say typically around 1,000, but there is no reason why 1,000. We cannot guarantee that this particular type of model for this particular application would need thousands of models to be good in any sense. This is very empirical. There is no theory. They are non-robust, but we are at the moment that we're delivering more and more decisions to this kind of AI models. And of course, this is called trustworthy AI, and the current models that we have, I wouldn't say that they're so very trustworthy, and large-scale deployment for critical application without human supervision is the way that we should go. However, of course, this is extremely useful in many cases. Again, for the medical application, if they use a second opinion, they're extremely helpful to doctors. And we also at Skoltech, we have a special project that works with a lot of Russian hospitals for develop different assistance for doctors, and they really report that this is sort of miracle that reduces the time for treating difficult patients and for diagnosis. And this is also, but we should not be blind, and we actually have to think how to form some sort of programs. And this is at the moment basic research. It's not sort of applied research. The issues that I have raised on the previous slide, this is really basic research. There is no straightforward way how it can be done. It's only by testing, proving, combining people working on computer science, mathematics, maybe even physics in some sense to understand what's going on. And another challenge is privacy and security, because you collect a lot of, how to build because the data set is anonymized. But actually, if you train a model on it's actually very difficult to anonymize data in a correct way. So it gives a lot of overhead to train models that preserve the privacy of the data. So it's quite easy that to given a trained model to find out whether the particular person was in the training set or not. And actually, it's a big issue. If there could be a risk if you release such a kind of open data set from the data collected from the people, you will break their privacy and the security. So privacy and security, there is a big challenge. This is my last slide with some steps. So I think a lot of investment has to be made into the basic R&D research for understanding the complexity, privacy, security, robustness, biasness, and explainability. So I would compare this to airplane industry. So in terms of speed, the airplanes nowadays, they fly approximately at the same speed, right? Like 50 years ago. But in terms of safety, they are much safer. So we have much less number of air crashes nowadays. It was achieved basically by having thousands of crashes, collecting the information from it, and improving the systems. And I don't think that we want this for AI algorithms, because we want to have much less problems from that, and we have to and in this case, the governments, I think this is the responsibility of the government, to invest into the basic research regarding the trustworthy AI. I think it's all what I wanted to say, and I will just stop sharing.
Thank you so much, Ivan, and thank you for highlighting some of these tricky issues with the machine learning of today's age, about privacy, trustworthiness, brittleness, robustness, bias. I think all these are very, very important and rightly put, because when we try to use these models at scale for population at large and supposed to be for public good, these issues are very, very important, and thanks for highlighting them. With this, I'll move on to our next and last speaker, Dr. Hemant Darbari. Dr. Darbari is currently a Director General of C-DAC, where he leads a pool of highly specialized scientific technical personnel. He is alumnus of prestigious IIT Roorkee. Dr. Hemant Darbari out advanced research in innovative and emerging technological domains. Over to you, Dr. Darbari.
You are on mute.
Is it okay now?
Yes, we can hear you. Thank you.
Okay, thank you, Gaurav. I think data rich to data intelligence. This is a very, very important session which we are conducting here, and a lot of people have talked about many things and how countries can navigate the water, and that's the topic on which we are deliberating. So data is akin to natural resource, wherein AI ML techniques can be used to design and develop products, and limitless powers of ICT for uplifting the humanity, global economic growth, and prosperity to safeguarding the national asset and the boundaries. These are the things which are very, very effectively used for conversion from data rich to data intelligence side. It's slides are not moving or what?
We can see them, sir.
Okay. So when we talk about data rich to data intelligence, it's imperative need for the data collection and analytics to be taken in the raw data to rich data and transform into intelligent data to act on. The process the intelligent data is critical for the exploitation of AI technologies like big data analytics, MLDL, NLP, speech recognition, decision management, etc. in various domains. I can take the example of a speech recognition system. When we do that, there is a huge amount of data set which is to be worked upon, and that data becomes the Bible for creation of the system. We have raw data, then we have to annotate data, in some cases anonymize data, and then we annotate, and then we use that for the development of the model. So these things become very important and very important component for building any real life system. And then the data becomes intelligent, and we can use that for the real life applications. So enormous data is required for method in investigations and analysis. So the raw data, which is there, that is to be very effectively analyzed, and the data science has come up in a big way, and those models can be very effectively created with that type of thing. And digital transformation not only monetizes, but also enables in decision making, and intelligent data critical for new development and technologies are the prime movers. So the big challenges to address are the inadequate research infrastructure and expertise, insufficient enabling data ecosystem, high resource cost, low awareness of adoption, effective regulation around privacy and security, and deficiency of a collaborative approach for adoption of the application. Here again, what you would like to see that the infrastructure which is generally available, that infrastructure, when a startup wants to work on, this portion is having a gap. We can build a toy systems. We can build the toy systems on a smaller model, but when you really want to go for a larger deployments and you have to have large data set, there we have a problem of infrastructure not available. So, or it is very, very costly. So what government can do is that we can very effectively bring these things to the developers and the startups to make these things happen. This from the data value allocation side, the meaningful data have commercial value. Reliable and pragmatic data for development of secure automated services. Then contextual data having various interpretation in machine translation. Then legalized and trust-based data sharing mechanism with due protection has to be seen, and transparent mechanisms to sharing data, and exploiting data and manually beneficial manner for R&D purposes, and define revenue sharing model for data that's raw, anonymized, and annotated data. So what happens is that when we are creating these type of environments, we have to very, very carefully craft the legal part of the whole story, because of the fact that privacy becomes very important. And that's where the anonymization becomes very important. So as we were discussing in the medical domain or any other domain, when we are trying to take this data from the government sources or other sources, then the anonymization becomes very important to be catered for. So the stakeholders' role is to build infrastructure for fast track and creation of the product, then protection and maintenance of ecosystem and ensure all fairness of use, evangelization fund for innovative solutions towards commercialization, and policy framework for promoting collaborations. Here again, I would like to say that in India, we are trying to build a fairly large infrastructure, which will be 210 AI petaflop system, which we are creating with a huge storage, which can be given to the startups and other industry partners. And we can have a collaborative innovation model through which we can accelerate the whole process. What happens is that the data and the compute, that will be made available. And using that, the bigger models can be done or bigger real life systems can be created. And then that thing can be taken. That's how the innovation to commercialization timeline can be compressed. That's how the whole thing has been visualized. And the government's role globally can be to enable high usage of AI-based products in government-controlled organizations, promote innovation to drive new era of growth in the society, nature AI-based digital business, use intelligent data and AI-based R&D, development of productions, and host AI portal as one-stop platform for all AI-related advancement, and that's what we are calling AI for all, and incentives and encourage mass participation by the way of conducting hackathons. From the hackathon, actually, we have conducted many hackathons within C-DAC and at the government level also. The results have come out very well. I mean, during the COVID period, we conducted the hackathon and we got something around 400 plus registrations, and all our research and development related solutions have come, and we are supporting them to the next level and the next level. and so that this becomes a product and that can be rolled out on a fast track. So we need to invest in tools, human resources, developing platforms, developing policies about legal sharing, data generation, data filtering, data collection, then data tagging, accessibility. So these are the things which will be required for the systems to be built and taking things to on a faster track. And that is where we have to invest in. So I want to conclude that India is poised to play a pivotal role in this revolution, and good beginning by establishing the state-of-the-art 100 petaflop HPC infrastructure. Param Siddhi has been installed, and the multi-country consortia enables us to leverage knowledge base, galvanize the research community to accomplish meaningful objectives, and we are a mental facilitate the mentors and startups, MSMEs, academia and industry, and synergetic revenue realization policy. What will happen is that if we can, multi-country consortia can be formed, and the domains in which the others are expert, we can bring them all together with a proper revenue share model. So that becomes a very, very good thing for taking these things to the human being. And then that will be a major effort which will C-DAC and India will like to put in. Thank you.
Thank you, Dr. Darbari, and thanks for sharing what you and C-DAC have been involved in and what is needed to in the next step of AI readiness for our country. And with this, I think we have covered all the panel speakers. And I'll probably try to ask a few questions which are relevant for us in this situation. So we heard from various researchers, people from government departments. So I think I'll just throw it open for anyone who wants to answer. So what do we think are the primary gaps in India's data value chain? Like what practices, tools, or policies can we institute to overcome these gaps? Mr. Prakash, Kumar, Dr. Darbari, any of you, or Sharmistha, ma'am? I mean, it's a very large question, but I thought hearing some views from you who have done it before will be good to hear.
Yeah, so thank you, Dr. Aggarwal. The problem is the basic understanding of what can be shared, what cannot be shared is something which is lacking. In fact, just before this session, I was part of a group which is now coming up with a second version of Ind architecture. Now, there again, the same problem. The departments don't understand the value and how do you architect the data? What is private? What is public? How do you give it? How do you share? And you don't architect and you don't develop everything. How do you cooperate and then it? Now, the policies are required on that, and that is what one which is already going on. And I'm certain the Ministry of Electronics and IT is working in that particular area. More we can have maybe the people from NIC or from METI who are here, they will be able to tell us.
Then, Mr. Ma'am, do you have anything to add to this?
Yeah, actually, we have been working with ministries and departments, and the basic thing which we have a problem here is that people are not very aware that we can transform our governance with AI. So we have to build that into our psyche. Means everybody has to be given capacity building. Means every officer in the government has to be given, because government has got a lot of data. It is data rich, and then we are at that portal where we know how to move ahead, and our main problem might be resources. The user will be having domain expert. We will be having the maybe supercompute platform. We are increasing over time, but then technical manpower is also required. So we have tried to democratize it. Within NIC, we have got 800 offices. district level and state level and all that. So what we are doing is basically we are allowing all the officers for capacity building. We have taken them to IIT Roorkee, one representative from each state. Then we wanted the second round to go through for machine learning and AI capacity building of our NIC officers. Then COVID-19 took place, so we can improve that also. So the thing is, I think our awareness has to improve, and it has to improve over time, because in the next 5 years, we will see major changes in India. And we have the government setup has to also build up in that fashion. Basically, GSTN and all are doing very well. That CBDT and all, these are the finance companies, finance organizations of government of India, which are doing very well in analytics and all. And in mission mode projects also, we have got data analytics dashboards and all that, which can be drilled down to find out what is the status of everybody. But the thing is proactive. These are all basically reactive way of seeing what happened. Like the Ministry of Drinking and Water and Sanitation wanted to find out how many of the cases were duplicate. What we needed, like in urban, what we did an active policy making by active intervention, AI intervention, and allowed the reduction of the workflow AI cycle. So like that, we have to basically increase our sensitivity among all the officers. We have got in all the ministries and departments. So everybody has to cater. Everybody has to be on the same line. Then only startups and all, everybody will find a good ecosystem where we can collaborate and explore things. Yeah, thank you.
Can I?
Thank you. This was, yeah, Dr. Darbari, please.
Yeah, so I think what has been discussed is absolutely correct, that there's a fear and there's a trust factor. Both the things are prevailing. So there is a huge amount of effort to be put by all to 3 steps, which is learn, unlearn, and relearn. I think this is what exactly the process everybody has to go in for. Because I recall when I developed the system for machine translation for Rajya Sabha, which is the upper house, there's a big fear that as soon as the mantra, which is the machine translation tool, comes into the system, they will be all jobless. And it was hard time to convince people that this is not to take your job, but assist you in doing the job. And that's a Turing test type of stuff we did, wherein the whole session of August 2007, I remember correctly, that we ran the system as it was running in the Rajya Sabha, and 1 translator and 1 vetter was given to sit on the mantra system. Full session, we did the exercise, and 10.5 hours to 2.5 hours was the difference they got. So absolutely camera ready copy, 10.5 hours with the manual intervention, manual system which was happening, and with mantra tool, it got reduced to 2.5 hours. So that was the game changer. Then they thought, okay, fine. I also told, right now you cannot go home, that is up to 2 o'clock or 1 o'clock till you do the whole work. And with this, you can at least reach home at 10:30. So this gave them confidence. And then finally, when the final presentation happened, I didn't give the presentation. These Rajya Sabha employees gave the presentation. And they said, okay, this is good. So that's why I was telling that the fear and trust, both the things are working, and working very much against the AI, because that is not the core part. The thing is that I think another discussion which we were having is that many new jobs have come up. We say, okay, fine, this job is gone, this is not there, but there was no data analytics or data science guys even just 3 years back. The huge amount of opportunities have come up. So I think my point is that in the whole process, if we can very effectively build this trust and remove the fear, that is the need of the hour.
Cool. Thank you so much, sir, and ma'am, for sharing your valuable remarks. Oh yeah, Mr. Prakash, yes, please go on.
So just to add to what Dr. Darbari said, see, you had mentioned in your, after some of us had made presentation, that how much of work has been done. Now, one is, where is it? Is it available at one source? That's number one. Number two, Government cannot do everything itself. So how do we democratize what part we can give to as a public good, not sell, public good, and make it equally available to large number of people? And it's ecosystem creation, and that is what we have done in to some extent in GST and many other some other organizations. So there has to be policy on it. Otherwise, there is a tendency in the government departments not to share even with a sister department. Absolutely. I mean, they just don't want to share. And this is not only our country. I have worked in other parts there also. This is almost similar kind of thing. And what Sharmistha talked about is the people that we don't have. In fact, we are structurally a private company with not-for-profit private company under Ministry of Finance. Took me 1 year to just get a 20-member AI team to be created. 1 year. And where I'm taking every decision to my board, nothing goes to the ministry because we have people from the government on the board. They need to be told. And the fourth part is what can go out, what cannot go out, what goes out, in what format it will go, how it will be shared, with all examples. Senior people, if you just go and tell them, show them the way Dr. Darbari explained, the user, he becomes your ambassador. You don't need to do anything. But then how do I do that? So that's important. So these 2-3 things, policy, people, these two, and what process we adopt, the same 3P gets applicable here as well.
Yeah, I think even from people outside government, I think I can speak for myself and many others. I think we are very eager to find ways to play a role in this nation building, right? I think all of us want to do it. Sometimes we are probably busy in our corporate jobs, but so it will be good, if there are more and more opportunities where, without sort of leaving your day job, if people like me and others, there are numerous in India. There's no dearth of talent. There are various places can become involved, even in a not actively, but even in a indirect way, even in a part-time way, even over weekends or whatever, to play a role here. As you said, we all have to do it together. I mean, if we have to sort of address the numerous problems that our vast country faces, it can't just be left to government and government organizations. But I think we have to create that platformization, that ecosystem, as many of you talked about, to enable this kind of partnership while taking care of all the privacy and related issues. And with this, I'll thank all the speakers. I think it was a fascinating discussion. Thank you so much for being part of this. And I'll hand it over to Neeraj to complete the session.
Thank you.
Gaurav.
Thank you, Gaurav.
Thank you all. I hope that this session will help the viewers better navigate the complex water, because now we have something concrete in this session, that policy, there should be a policy of sharing, what can go out, what can't go out, and there should be process for sharing, and we have to involve people. So thank you all our keynote speaker, Dr. Gaurav Aggarwal, Mr. Prakash Kumar, CEO GSTN, and all the panel member, distinguished panelists. Thank you so much. Thank you.
Thank you.
Thank you.
Thank you.